Hello, if you find this video on your FYP, then I say a very big congratulations to you, especially if you are a mathematics student struggling with integration. In this video, I'll be teaching us the indefinite integral. To start with, what is integration? Integration is just the reverse process of differentiation. And in this video, I will just be showing us the integral of two functions, which are the polynomial function and the trigonometric function. And after that, we move on to examples where we can see how to apply the integrals. To start with, we have for the polynomials, we have the integration of x to the power of n. So how do we integrate this? So what we do is we write x, that is x, and then we add 1 to this all over, then we divide it by the power, that means n plus 1. Then we add the constants. When we are dealing with indefinite integral, we always add the arbitrary constant, which is c. Then moving on to the next one, then when we integrate sine x, we get minus cos x plus c. And then the third one, we have sine x plus c. And then moving on to the fourth one, we have the integral of sec square x dx. We have that is tan x plus c. So these are the integrals of these functions. Then we can move on to the examples now. So the solution to these examples here, the first one, we have the integral of 3x squared plus 4x minus 5 with respect to x. Now this equals to, we have 3x squared. Now the power of x here is 2. Now following this, we add 1 to it and divide it by that. So we add 1 here, 2 plus 1, all over 2 plus 1. Then we have plus 4x. Now we have x here, the power here is 1. We call it invisible 1, right? Then we add the 1 and also divide it with 1 by 1 plus 1, right? Then we have minus 5. So we have 5, there's no x. So how are we going to deal with that? So what I'm going to do is that we know that here it is x to the power of 0, because x to the power of 0 is still 1, right? Then we had 1 all over 0 plus 1. Yeah. I can add my c now. Then we have 3x. This is 2 plus 1, 3 over 3 plus 4 x to the power 2 over 2 minus, this is 5x over 1 plus c. Right? 3 cancels 3 and 2 here 1, 2 here is 2. Then we have x raised to the power of 3 plus 2x squared and 5x plus c. So we are done with the first example. Then move on to the second example. So here we go. This is the second example. Now how do we simplify this? So we are going to do some kind of work before we actually start integrating. So there's a way we have to simplify this. So we can write this way. Now this equals to, we can write 1 plus tan square x minus with bracket sine square x plus cos square x. Now this in the bigger bracket dx. Alright. Now we know that from our trigonometric identity, we know that 1 plus tan square x is sec square x. So this is not magic. 1 plus tan square x is sec square x. That is from the trigonometric identity that we know. Then we have minus. Now sine square x plus cos square x, from the same trig identity that we know, it is 1. So we have minus 1 here. And we have the x. So what we have here is sec square x minus 1 dx. Now looking at this, we can write this as, we can just split the integral. So we can write sec square x dx minus the integral of 1 dx. So what I've done there is just to split it. We can split the integral, right? Differentiate, this is a term, this is a term. So we can integrate each term, right? Now from what we have here, when we integrate sec square x dx, it is tan x, right? So we have this one become tan x, and then minus, now this one, this x, right? So what I'm going to do here is, whenever we have a constant, right, we have just like when we had 5 here, remember what we did? All we need to do was just write 5x is power 0. So now we have 1 here. So what we need to do is write 1x is power 0, right? Which is the same thing as x is power 0. So that means here we have x raised to the power of 0 plus 1 all over 0 plus 1, then we add the arbitrary constant, right? Then let's just simplify all of this. Then we have tan x minus, this gives x, and we have the arbitrary constant c, and then we are done. So this is the integral of this. All right, so this is the end of it. Thank you for staying through. If you have not started following me, please ensure that you click on the plus button here on TikTok to start following me so that you can get videos whenever I upload them. So see you next time. Goodbye.